problem, I'm being asked to take this piecewise function and find each point of discontinuity and to find out if it is removable or not. So it's a piecewise function. And what I'm going to do, first I'm going to see, well, do I think there might be a point of discontinuity here? Well, if a function is continuous at a point, it means that the limit as x approaches every point in that function, or it approaches that point, is equal to the function evaluated at that point. We have a limit here as x approaches c. That means it is a two-sided limit. It has to be from both sides. The exception is if it is an end point of the function, in which case, if it is a left endpoint, then it has to be continuous as I'm approaching it from the right, from the positive side. And if it is a right endpoint, it has to be continuous as I'm approaching it from the negative side. So if I don't satisfy those conditions, then I have a point of discontinuity. Well, what might be a point of discontinuity in this piecewise function? Well, piecewise function is made up of two separate functions, each with their own separate domain. So let's look at them individually. First of all, I'm looking at the function 3 minus x. Well, I'm guessing that that's just going to be a straight line, and that function is going to be, if I just had that function alone, it would be continuous from negative infinity to positive infinity. There's nothing in that function that indicates that, that I wouldn't have satisfied the conditions of every point being continuous. And this function too. Although I have a denominator here, there's no variable in the denominator. So that also is just going to be a straight line, but it's going to be over this domain. So the only place I can possibly see that there might be a point of discontinuity is looking at the domains here. It looks like as x approaches 2, I may have a point of discontinuity. Every other place on these functions, I'm going to satisfy this condition for continuity, again, that the limit as x approaches c of the function is in fact equal to f of c, just substituting c in. So I'm going to start this with a graphing approach to this problem. I'm going to first enter in the first function, 3 minus x. And I'm going to go zoom 6, and that's what it looks like. Now, I have a problem. That this is a piecewise function, and I'm only looking at for x less than 2. So I'm going to show you a neat trick as to how to graph a piecewise function on your TI84. So if I go back to my y equals, and I'm going to put my 3 minus x into parentheses. And I am going to divide that by an inequality. So I'm going to divide that by the inequality. I'm going to press that. Inequalities can be found if you look at the math button. Right above it, it says test. So I'm going to go second test. Oh, wait a minute. I got to go back to y equals. I want it for x less than 2. So I'm going to go x. Then I'm going to go second test. And I have these inequality signs. So it says less than 2. So I'm going to go down to the less than. And I hit enter. I could have pressed 5. And I'm going to press 2. And I'm going to close my parentheses. So the inequality x less than 2. When you put it into the calculator, where this is true, it returns the value 1. And where this is false, it returns the value 0. So if I'm looking at a number line here, 0, 1, 2, 3, 4, 5, any x value less than 2 is going to return the true value, and it will be 1. Well, if I divide my equation here, 3 minus x by 1, it just stays 3 minus x. But any value greater than 2 for x returns a 0. Well, if this over here is 0, I'm dividing by 0, it's undefined, it won't show up on the calculator. And just to show you, I'm going to go graph, and there's my line, and it stops right there at x equals 2. Well, I'm going to do the same thing for the other part of the function. I'm going to go down here, I'm going to go, well, parentheses, x divided by 2, close parentheses, plus 1. Now I needed to put that whole thing in parentheses, because they're going to make this division sign by the inequality. So let's go second, insert another parentheses. I said second, insert another parentheses right there. Okay. And then I'm going to go, sorry for taking so much of your time here. I'm going to go divided by parentheses x second test greater than 2. Close parentheses. Zoom 6. There's my first one. There's my second one. And you can see that this is a piecewise function. I'm going to zoom in on it just a little bit more. So I'm going to go window. I'm going to go like from -2 to 6. And my y values, I'm going to go from, I don't know, -2 to 6 also, and see what it looks like. So you can see the two functions pretty clearly right there. And there is indeed a point of discontinuity at x equals 2. So there's a point of discontinuity, and this is how you write it. You write, well, if the question is where's the point of discontinuity, you write x equals 2. Now I'm just going to write here point of discontinuity. Now the second question is this point of discontinuity removable? Well, the answer is no, because I have different limits coming from the left, from the negative side, as I do coming from the right. If I had the same limit coming from the left and coming from the right, then I could define a point and make it continuous. But since this is a jump discontinuity, I'll write that down here, big letters. This is a jump discontinuity. There is no point that I can assign at the value of x equals 2 that would make those two connect and make that a continuous function. I just want to show you quickly again, the other calculator that I like to use right off the internet is desmos.com, desmos.com, and you can see I was able to enter in both these functions, and then if I put in brackets the domain of each function, it comes up as two piecewise functions. And if I kind of click right down there at the end of the red function, you can see it says at 2 it's undefined, and up here on the blue function, well, I'm going to get really close. Again, at 2 it's undefined. So there's a lot of nice features of this that make it easier to use with a lot of graphing.